inequalities, order of real numbers. So we're going to build out inequalities. Inequalities are symbols like less than or equal to, greater than or equal to. So we have less than or equal to, and then we have greater than and greater than or equal to. The way we remember less than is L looks like the less than sign. So the other one is greater than. When we're equal, we include it. When it's not, we cannot include that that boundary. So you see the variable, you see the inequality, you see the boundary. So x is greater than 2, x is less than 2. We see that L that reminds us for less. X is greater than or equal to 2. So here we can include the values of 2. X is less than or equal to 2. We would again include the value 2. When x is greater than 2, 2 is not a solution. So I look at the variable. When we see that x, I see it as, I read it sometimes, the solutions. The solutions are greater than 2. The solutions are less than 2. The solutions are greater than or equal to 2. And this is a compound inequality. So these are two statements. So when we see this, we see two statements. We see x is greater than -3 and x is less than 1. So it has to be true for both. That's the important thing. Must be true for both. So it has to be greater than and it has to be less than 1. So that's a very small window of solutions here. The other one would be an or statement. So I'm sure we'll see some translate the statement into symbols. -2 is greater than -6. Yeah, there's no variables there. X is less than or equal to 5. Good. So -2 is less than 5. -3 is greater than -4. And we see that. -6 is less than or equal to -2. 4 is greater than or equal to 1. Nice and easy, nice and gentle. 4 is greater than 1 and less than 5.4. So 4 is greater than 1 and less than, well, we wouldn't write that, less than 5.5. So 5.5, that's not how we would write that statement. That would be an incorrect way if we translated it how we saw it. So we have to write two statements. 4 is greater than 1 and 4 is less than 5.5. So notice how we had to write a new statement. And now let's rewrite this. We could write this as 1 is less than 4. Notice it's eating the 4. It's eating the 4 when I rewrite it. And 4 is less than 5.5. So if we were going to write it in one statement, we would do, that is the correct way of writing 4 is greater than 1 and less than 5.5. So we see the 4 is greater than 1 and we see 4 is less than 5.5. So good tricky one. 0 is greater than -2 and 0 is less than 3. So let's get that common 0 in the middle again. So now we can write it as a statement. -2 is less than 0, which is less than 3. That's the real way to read it, but that's okay. -5 is between 1 and 7. Translate statement. -5 is between 1 and 7. Okay, so let's write the -7. Let's write that -5 is between, I don't know, was there an example with that? Is between? No. That's an interesting one. So I don't know if we do the equal sign or not, but that's how I would write it. 3 is between -5 and 5. That's how I would put 3 between -5 and 5. It's an interesting one. 3.5 is greater than 3, and 3 is greater than 0. So 3.5 is greater than 3, and 3 is greater than 0. So we would always use less than signs in compound inequalities. Reminder there, use less than signs with compound inequalities. Just a little note. And the other way you can know is they need to be in numerical order. So 3.5 is bigger than 0 numerical order going left to right. Negative 3.5 is less than -3, and -3 is less than 0. So that's good. Negative 3.5 is less than -3, which is less than 0. Notice still in numerical order, so that works. The number n is greater than 6. Nice. Our solutions are greater than 6. The number n is less than 12. Okay, classify each statement as true or false. Good, so we're going to look at those. So is 1 greater than -5? Yes. Remember how compound has to be true, true. Is 1 less than 6? True. So that is true. So remember that. So is 2 greater than -8? Yep. Is 2 less than 5? Yep. So this is a true statement. Is 0 less than 3? 0 is less than 3. Is 0 greater than 1? That is false. And also notice this is not in numerical order. So notice not in order. So that's just a little something. Is -2 greater than 3? That's true. Is -2 less than 3? That is true also. So this is going to be true. By the way, this is considered false. That's true. So we're good with that. Classify each statement as true or false. 4 is less than or equal to 8. That is true. And it's okay, that's not a less than, it's not numerical, it's only the compound that we are more concerned. And remember, is the inequality eating the bigger number? That's the sort of the lower school way of figuring out inequalities. So this is true also. 13 is less than or equal to 22. This is going to be false. -16 is not greater than -9. And is -2 greater than -3? That is true. Classify each statement. So we're going to have to do the absolute value. So we're going to have to simplify first. So 2 greater than or equal to -2. That is going to be true statement. Let's simplify this. Absolute value -2 is not 0. Is 2 less than or equal to 0? That would be false. 2 is not less than 0. Let's simplify. 0.5 less than -0.3. That's going to be false. No positive number is ever going to be less than a negative number. We have 5 less than or equal to 10, which is a true statement. Remember, absolute value just wants distance. Things to remember. Absolute values measure distance. It doesn't care about direction. That's how I teach absolute value. Numbers have direction and distance. So the absolute value just wants distance of a number. Solve, and this is the element. Find all the values in the domain. So this is the element. So each of these items, I forget what they're called. Each of these, are they called elements? No. Each of these numbers are a part of the set, and replace it each with the values in true. So, and then tell me which ones are true. So we'll put that in a solution set. So we get, let's do, so 2 times -3 less than 4 is -6 less than 4. That's going to be true. We're going to write a whole bunch of stuff. 2, -2 less than 4, -4 less than 4. That is going to be true. Is 2 times -1 less than 4 is -2 less than 4. That is going to be true. Is 2 times 0 less than 4 is 0 less than 4. That's going to be true. Is 2 times 1 less than 4 is 2 less than 4. That's going to be true. Is 2 times 2 less than 4 is 4 less than 4. That is going to be false. It is equal to, but it's not less than. And then is 2 times 3 less than 4 is 6 less than 4. That also is going to be false. And we're going to have the solution set is going to be -3, -2, -1, 0, 1. That's it. How many of these we're going to have to do? Hopefully not a lot. So we have 3 times -3 less than 3 is -9 less than 3. That's going to be true. Is 3 times -2 less than 3 is -6 less than 3. That's going to be true. Is 3 times -1 less than 3 is -3 less than 3. That's going to be true. 3 times 0 less than 3 is 0 less than 3. That's going to be true. 3 times 1 less than 3. It is 3 less than 3. That's going to be false. Is 3 times 2 less than 3 is 6 less than 3. That's going to be false. And last one is 3 times 3 less than 3 is 9 less than 3. That is going to be false. That's horrible false. False. So the solution set is going to be -3, -2, -1, 0. Let's make sure we did that. Yeah, we did okay. That's okay, and that is correct. Let's do -2 times -3 less than or equal to 6 is 6 less than or equal to 6. That is true. It's not less than, but it is equal to. -2 times -2 less than or equal to 6 is 4 less than or equal to 6. That is true. Is -2 times -1 less than or equal to 6 is 2 less than or equal to 6. That is true. Is -2 times 0 less than or equal to 6 is 0 less than or equal to 6. That is true. Is -2 times 1 less than less than or equal to 6 is -2 less than or equal to 6. That is true. -2 times 2 less than or equal to 6 is -4 less than or equal to 6. That's going to be true. Negative 2 times 3 less than or equal to 6 is negative 6 less than or equal to 6. That is going to be true. So all of the solutions. So my solution set is negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay. Is 1 plus 1 less than 3? Is 2 less than 3? That is true. What? Oh, Mr. Mac. Why did I start with 1? That was weird. Is negative 3 plus 1, which is negative 2. Is negative 2 less than 3? That is true. Is negative 2 plus 1 less than 3? Is negative 1 less than 3? That is true. Is negative 1 plus 1 less than 3? Is 0 less than 3? That is true. Is 0 plus 1 less than 3? Is 1 less than 3? That is true. Is 1 plus 1 less than 3? Is 2 less than 3? That is true. Is 2 plus 1 less than 3? Is 3 less than 3? That is false. It is not less than. And then 3 plus 1 less than 3 is 4 less than 3. That too is false. My solution set starts at negative 3, negative 2, negative 1, 0, and 1. Negative 2 plus negative 3 less than or equal to 0 is negative 5 less than or equal to 0. That would be true. Is negative 2 plus negative 2 less than or equal to 0? Is negative 4 less than or equal to 0? That is true. Sorry, my daughter just negative 2. Negative 2 plus negative 1 less than or equal to 0. Negative 3 less than or equal to 0. That is true. Is negative 2 plus 0 less than or equal to 0? Is negative 2 less than or equal to 0? That is true. Is negative 2 plus 1 less than or equal to 0? Is negative 1 less than or equal to 0? That is true. Is negative 2 plus 2 less than or equal to 0? Is 0 less than or equal to 0? That is true. And is negative 2 plus 3 less than or equal to 0? Is 1 less than or equal to 0? That would be our first false. So my solution sets are negative 3, negative 2, negative 1, 0, 1, and 2. Okay, 3 more. Systematic 1 minus negative 3 greater than or equal to 0 is 1 plus 3 greater than 0 is 4 greater than 0. That is true. Is 1 minus negative 2 greater than or equal to 0? Is 1 plus 2 greater than or equal to 0? Is 3 greater than or equal to 0? That is true. Is 1 minus negative 1 greater than or equal to 0? Is 1 plus 1 greater than 0? Is 2 greater than 0? That would be true. Is 1 minus 0 greater than or equal to 0? Is 1 greater than or equal to 0? That is true. Is 1 minus 1 greater than or equal to 0? Is 0 greater than or equal to 0? That is true. Is 1 minus 2 greater than or equal to 0? Is negative 1 greater than or equal to 0? That is false. And is 1 minus 3 greater than or equal to 0? Is negative 2 greater than or equal to 0? That also is false. My solution set would be negative 3, negative 2, negative 1, 0, and 1. Ooh, I like this. Quantity negative 3 squared greater than or equal to 8. Is 9 greater than or equal to 8? That is true. Is quantity negative 2 squared greater than or equal to 8? Is 4 greater than or equal to 8? That would be false. Is the quantity negative 1 squared greater than or equal to 8? Is 1 greater than or equal to 8? That is also going to be false. Is 0 squared greater than or equal to 8? Is 0 greater than or equal to 8? No, it is not. Is 1 squared greater than or equal to 8? Is 1 greater than or equal to 8? That again is false. Is 2 squared greater than or equal to 8? Is 4 greater than or equal to 8? That is false. And 3 squared greater than or equal to 8 is 9 greater than or equal to 8. That goes back to true. So we only have 2 solutions. That is negative 3 and positive 3. And the last problem, similar to it. So negative 3 squared less than or equal to 9. Is 9 less than or equal to 9? That is true. It's equal to it. Not less, but it is equal. Is quantity negative 2 squared less than or equal to 9? Is 4 less than or equal to 9? That's true. Is negative 1 squared less than or equal to 9? Is 1 less than or equal to 9? That's true. Is 0 squared less than or equal to 9? Is 0 less than or equal to 9? That is true. Now, 1 squared less than or equal to 9. Is 1 less than or equal to 9? That's true. Is 2 squared less than or equal to 9? Is 4 less than or equal to 9? That's true. And the last problem, I did 3 cubed, sorry. 3 squared is 9 less than or equal to 9, and that is true also. So all of the numbers are solutions, so negative 3, negative 2, negative 1, 0, 1, 2, and 3. Done. All right, yeah, this is basic. I wouldn't really call this algebra work in chapter 10. I love how we're doing this in chapter 10. I would call this more pre-algebra concepts. Absolute values or pre-algebra. Squaring should be, the introduction to it should be pre-algebra. So we're just conferring and reaffirming, strengthening our pre-algebra skills here. Good luck.